All right, then I guess I'm starting. Hi guys, I'm David. I talked actually a few weeks ago about React Native on this meetup, and there was a lot of good questions. So I thought, okay, maybe people are interested in that kind of topic. So let's talk about it again, but this time in a little bit different way. So my topic today is demand-driven architecture, or demand-driven apps. And before I go into detail, does anyone have any idea what that could mean? Anyone? What is a demand-driven application or demand-driven architecture? No one? Okay. So demand-driven architecture is kind of, it tries to solve a very specific problem. What problem it is, I will tell you in a bit. But it is kind of the next iteration, the next organic iteration in how we design our applications. So before we go into detail, let's talk about the problems of the current architecture. Doesn't want to go? Okay, the problems of the current architecture. And by current, I mean client and server architecture. You have a server somewhere, you have a client somewhere, be it a website or an app or a TV or whatever, and it consumes your server, the data that you have on your server. It does something with it, it downloads all that data, and then you have some kind of application. So in a case, when we think about an app that, for example, lists posts made by users, we would, if we try to structure that up, we would say we have like somewhere an endpoint that provides the posts that the application can download. Somewhere we have like a user endpoint, and the client itself merges that together to an app that the user can see. But if we take a look in what actually this means, what most of people do just by default without actually thinking about what they do, is REST. So is the problem of the current architecture maybe REST? Of course, the question why REST? REST works really good so far. Like, we're using it for everything. We don't have problems with it. Maybe we had some problems with it, but we were always like able to make it work somehow. But the thing is, REST only works really good if you add this in a really small scale. Or if you have like big chunks of data and you want to give this data to another entity. You have big documents, and someone else can download these documents and parse it and put it in a database or something like that. But nowadays we don't really want to do that. We want to do exactly the opposite. We don't want big endpoints, we want very small ones. For example, we only need, for example, the user name or the user age or something like that. We don't want the entire user object to download. It also works really great if we need to chunk our data into logical components. For example, we have a user table, so it makes sense that we have a user endpoint which reflects that kind of data. So usually when we do REST, we kind of design our API around our tables that we have in our application. But to actually go into detail what I mean, let's try to design a REST application right here. So imagine we never heard of Facebook before. I think, hey, I want to make an app. I call it Davebook, and I can post things, I can comment on things, and somewhere in the future, maybe I make some money with it. If you take a look here at some, is it visible? I hope it is. If you take a look at what we have here, for example, we can deconstruct it and say, how would we design our models around that? So we can say maybe we have a post here or something like that. Like the obvious component that we need. Each post is made by a user, so we also need somehow to have the user data somewhere saved as well. And eventually we have comments on each post, which are, again, made by users. So if we try to design this as endpoints in our REST system, we would probably start something like we have a timeline endpoint or something like that. And in this timeline endpoint, because we are doing strict REST, we try to decouple everything and have it in local and try to reduce data duplication. We would do something like this. It references post 1, post 2, post 3 with URLs, and we say, hey, here's the data, you can download it here. But since each post is made by a user, we would probably see something like this. We have each post is referencing a user. So we have now, just by this, we have 7 endpoints that we have to query, 7 data documents that we have to download for our app. But it doesn't stop there, because we also have comments, right? So we have, each post has like 1 or 2 comments, and again, if we would decouple that into REST modules, we would probably have it separate as a separate endpoint as well. And again, because each comment is made by a user, we have, again, a user somewhere in the mix. So from a programmer's standpoint, if I look at this, I would say, hey, this is a really greatly designed system, a very good design system. Everything is independent, everything is like decoupled. And we have no data duplication at all. We have only the user information inside the user endpoint. We have only the post information inside the post endpoint, and if the client wants more, he can download that data if he wants it. But if we take a look at how we would actually design the front end for it, we would probably do something like this. We say we have a loading indicator that says, hey, there's some loading going on in the background. And then after a while, maybe we get like the first post back. We get like the list of posts and we know, hey, we have 4 posts. Let's show 4 loading indicators or something like that. So the client knows that there comes things. But here's the thing. What if, for example, we get the 4th post before the first one? How do we do that? What if, for example, what if the second one gets in timeout? What exactly when we try to load this, the 3rd post, the user goes into a train and he loses connection because he's on a phone? Then how do we handle all these edge cases that we need to take care of? Eventually, if we have a good connection, we end up with our app and our experience that we wanted. But in most cases, we probably don't. So there are obviously some problems here. We have to do this really big amount of data orchestration. We have all these endpoints and we need to download all of them at once, and then we need to somehow orchestrate in which order they have to go in so the content doesn't jump around. Then we have all these edge cases that we need to take care of, right? Again, what if the comment doesn't load? What if the 3rd comment downloads before the first one? What if the 3rd post downloads after the 4th one or something like this? We have to take care of all these edge cases that the user will not understand. We have many points of failures. Right now, before that, I showed you we had like 7, 8, 9, 10 endpoints, and each of these endpoints is a network request. It can fail, and it will very likely fail if we're dealing with the user on mobile devices. If the user is in a train or something, and then he suddenly loses connection, then maybe the half of our endpoints doesn't load. What do we do then? Another thing is because we decoupled our data so well is we have a lot of data to download, right? We have, for example, in our example before, we had the name of the user in there, but we would download the entire user document to get that data. And we only use the username and we throw away all the rest of the data, which is obviously not good. Another thing is one part always waits for the other. What I mean with that is, imagine, for example, we want a photo inside the user profile or something like this. We have to go to talk to the server people and say, hey, inside this API endpoint, we now want a photo. So even though we already have it kind of finished in our app, we have to wait until the new version of the API is deployed. Or the other way around, if the server people already have that in there and we don't use it in our app, then it would mean that we download that data, that information, and we just throw it away, we don't use it. So we need a different solution, right? What many people tend to do is to just say, okay, we have an app, let's design our endpoints around that app. Something like this. We have an endpoint that says get posts and comments, which just returns everything, right? All the posts that we need, all the comments that we need, all the user information that we need. And maybe if we have a user profile, we do the same thing again. If we have a search page, we do the same thing again. So we all have endpoints that reflect a view in our app. Now, again, if you would let that load like before, it would look something like this. We have a loading indicator in the beginning that says, hey, data's loading. But then, because we just wait for one big request, it would just load and load. And at some point, hey, here's your app, It's a very bad user experience to just let it load and suddenly everything pops up at the same time. So again, we have problems here. We have a lot of endpoints. We have a lot of duplicated data. Oops, that should not come at the same time. We have a lot of duplicated data because all these endpoints contain mostly the same information. If we need the user object in every endpoint we have, then each of these endpoints contains that user information. We have high maintenance costs because whenever we need to change, for example, if we change the schema for the user, we have to update all of our endpoints. We have like a cascading change through the entire application because we need to touch everything. And again, like before, one part always waits for the other, in this case even more, because if we need a new photo for the user, we need to put it in all of our endpoints, and one part always waits for the other. So we need a solution, right? We need something that is better than that. We need something that can handle all these edge cases for us. So what can we do? We can we can stop the endpoint overload. We can say, instead of having a million endpoints, we only try to have the endpoints that we actually need for our application and nothing more. We shift the ownership over data from the server to the client. If we don't try to pre-process data and say, look, I have this document, you can download it and use it for your app, we now say, hey, client, you know what data you want. You want, for example, to use a profile picture. Just tell me that and I give you that data. The server should not provide the data in big documents that are there for download. Again, instead of just providing these documents, the server returns exactly what the client needs and nothing else. We say if we have a list with posts and comments, the client will say, hey, I need posts and comments, and maybe the username with that, and it gets exactly that and nothing more. And the very interesting thing about this is that this is kind of a solution that two very big companies came up at the exact same time, which is Facebook and Netflix. Facebook recently announced Relay, which is their kind of take on this problem, in which they allow React components to specify query fragments that tell exactly the server what data they need, what this component needs to operate. You can argue that maybe on Facebook's architecture it makes sense because they have a really big graph that they query with information, and it's just natural that they get kind of pushed into that direction. But Netflix before had a REST API, a really, really big REST API that they were actually talking a lot about. And yet, independently of Facebook, but because Facebook didn't announce it that they had that, they came up to the exact same solution, to a solution which lets the client specify the data they want. And that brings me to another third part besides Netflix and Facebook, Ohm. Ohm is a ClojureScript wrapper for React. And because it's a ClojureScript wrapper for React, we can go everywhere where React can go. Since we have React Native now, we can use Ohm and ClojureScript to go to native devices. So we can actually write our applications in ClojureScript.
Can you just clarify, people may not be familiar, what is ClojureScript and perhaps Clojure and
I will go to that later.
Oh, okay.
Actually show examples. So the really interesting thing about this, before it was just a React wrapper, but since Facebook announced Relay and Netflix announced Filecore, the maintainer of Ohm, David Nolan, tried to pick out the best parts of Relay and the best parts of Filecore and combine them into Ohm. So he tries to build like a hybrid solution that arguably is better than either of them. So before I go into details, warning, there's ClojureScript. So if you never saw ClojureScript before, it's a Lisp dialect. So here's like a short example how you can actually describe a function, how you can call a function, how you can define a vector, which is basically a kind of array. It works a little bit different, but you can use it the same way as an array, and a map, which is a dictionary. ClojureScript. So in Ohm, before that, if you want to write a React component, we would do something like this. Again, ClojureScript code. So we inside here, I tried to go over that really fast. We describe our post component, and we say, okay, on rendering, render a view, and inside that view, two text boxes, one with username and one with content. View is a UI view here, and text is a NS text field. So it's not a browser or anything or a div or whatnot. These are actually native things that you're playing around with. The interesting thing about here is to get that data, this username and this content, we query something called all the props of this current component. So our component already says that I need this data to operate, but I don't care where it comes from. I just need someone to pass me that data so I can display things. This is how currently React kind of works. So with the next iteration, we now say our component has these query fragments in there. So again, to go over it really fast, we have a query function that just returns a vector that says I need content and user, but out of this user object, I only need the username and nothing else. So this is like our query now. It's just a vector, just an array kind of thing that we return. The important thing here is that it's a static method. So even if we don't have an instance of that yet, we can take this component and say, hey, tell me exactly what data you want so I can get that data for you and initialize you with that. In Ohm itself, if you want to, if you have multiple posts, you also need some way to identify them. So if you to kind of keep track of them, what you would do is you have to create a second static method called ident. This method gets called with all the data that the component would receive. So I'm giving you all the data and say, okay, based on that, how can I identify you? In this case, we just say, okay, you can identify me by ID. We just say post by ID is now a reference to this current object that we have. So later on, when you say, give me the component for ID 5, you can use this, and then you get the exact component back. This probably doesn't really make much sense yet if you don't have, if you don't see the timeline component yet, which would look something like this. Again, we have a static method. We have a static method in the beginning that returns a query. But inside here, instead of just providing a query itself, we say, post component, give me your query, so I can compose this query with the query that I currently have. I say I want a post list, and out of this post list, I only want as in the previous slide, only the content, the ID, and the user, but only the username. So this construct here would just go into, oops, wrong direction. So this construct here would just go inside here. It's just getting replaced with it. So we have this like really long query that says, I want a post list, but out of this post list, I only want content, I want the ID, and I want the user, but only the username out of that. In the render part itself, we just say, take me this post list and map it into post components, and then we display it. And this is actually also what I want to demonstrate in a little live demo to show how powerful this is and that it's actually usable. So let me try to mirror my display somehow. Just a moment. Okay. So what I have here is, I just have a very simple Bootstrap app. This is a React Native app. This is a React Native app that just is compiled by ClojureScript. So if you take a look at, what I want to demonstrate here with this is that another cool thing is if you decide to use ClojureScript for your next application, you can do something like, in Lisp application, you usually work with a REPL, which is just a shell that executes what you give it and gives you the result back, so you can verify if your code works in the correct way. The cool thing is that you can connect these REPLs to all kind of things. So in this case, what the shell here that I have down here is connected to this simulator. So it doesn't have to be a simulator. It could be a real device that I have in my hand right now if I set it up in that way. The cool thing about this is that inside here I have the app state. It's just saying welcome to Om, right? Which is the text that we display here. Because I'm inside this application right now, I can, for example, dereference that state, and I can see live that I have the state. At the same time, I can also interact with it. I can say, give me that app state, and did I call it message? And for example, change the text live to iOS meetup. And you can see that it like evaluates it on the spot, and you get right away the new thing. Again, this is not a website. This is a native application that you're working with. But what I want to show you is, of course, the cool parts. So let me. Is it this? I don't want to. This stuff here. Again, so right now the simulator looks exactly the same as before, but now I'm taking my current buffer, everything that I have inside here, and I send it over to my iOS device and say, hey, execute me that. So as soon as I do that, you can see that it updates. So what's going on here? Again, this is the same example that I just showed on the big slide. Is I have this query component here that says I want the ID and the user and the content of this post. I just style it a little bit here, and inside the post component, I take the subquery down. And if you take a look at the server, you can see that the server is requesting this query fragment here. Maybe I should make it a bit bigger. The client is requesting exactly this query fragment here, which is exactly what we specified in our app. Inside my little Python server, I just parsed it down, and I say, okay, the client wants ID, but the user, but only username, and the content inside a post list. So I'm returning in that kind of data. I can also show here that I'm not cheating. So if I execute this against my local server, you can see that I'm only getting this data back and nothing else. So the server understands that. If I, for example, cut out the ID, then in return, I get the same thing back, but without an ID. So the server knows understands the query that I'm sending it and can react accordingly to that. One thing I want to also demonstrate is that because you can compose queries this easily, and you basically never have to really update your server. For example, inside here, this is my post component, right? So inside here, I now want to display, for example, the age of the user. I say, give me an age component, age fragment. Inside here, the syntaxes might also not be known. What this basically does is it says, give me the keys ID, user, and content out of this props that I currently have. Instead here I say, give me username and age out of the element user. So it's just deconstructing it. again, now I have this query fragment inside here and say, I have an age object now, so let's use it. So imagine instead of the username, I want to show something like hope that's, and inside here I show the age. Again, if I have my simulator on the right side, I can send this buffer over, and then it just updates it on the spot. And my query, if you take a look at the server, changed, and it now says, I want age as well, so give me that information. And it's just composing that live on the spot, sends it to the server, gets the result back, and uses this result. Let me find my slides again. There was mirroring. Here, okay. Where's my slide? Here, okay. So what are the advantages? What are the advantages of using an approach like this in regards of what we had before, where the server is pre-constructing this data that we need and we just download it? On one side, we have the server doesn't need updates anymore, right? We have one endpoint that understands the query that the client needs. If we need an update on the API side, it's probably authorization, authentication, stuff like this, but we should not need time to add new endpoints because our server already understands what the client wants. So we can reduce all of our APIs, all of our endpoints that we have to one general one that just understands what the client wants. The downloaded data is as small as possible because we say exactly what we want and we don't get anything else back. If no one asked for an ID field or something like this, we don't get it, so we don't need to download it. So the server just doesn't provide it for us. We don't have AJAX coordination anymore. Either the data is here or the data is not there. This is a reactive approach. So if the data is there, it will just update our components live on the spot with the data or with the new data. We have the focus is on the client and the components. Instead of thinking, hey, if I want to implement this kind of thing, I need to now update the server first. You don't need to do that anymore. You just write your components, you concentrate on the client because this is really what matters and not how your data looks in the back. You want to be up to hour, we want to create cool applications and not cool APIs. Another advantage is component reusability. If you have a component that, for example, shows the user profile and it relies on the user name and the name of the user and the age or something like this, it doesn't matter where you put this component. Even if you put it in a completely different spot into your application, it will still work the same way because the component itself tells the server which data it needs. Another cool advantage is you can use it right now. It is still in alpha, but the next beta is coming in probably a few weeks. You can use it, you saw it, it works, and I think if you take a look at Relay and Falcor, they started open sourcing things, but I think there's not everything there yet. So some components might still be missing, but now with this approach, you can use it right now. And another advantage for people that like ClojureScript, you can use ClojureScript to write your apps now. I think that's really awesome. A few resources, if you guys are interested in these kind of things, are listed here. Omnext by David Nolan is a very interesting talk about why he decided to model it in this way. Why Falcor by Jafar Hussain, I hope I said that correct. The guy responsible for Falcor at Netflix also explains why exactly they came up with this solution, which problems they had with REST before, and why it was just logical for them to go into the next iteration with this kind of approach. And thirdly, Relay and Application Framework for React by Joseph Savona, a Facebook guy. I think he's working for Instagram, on the Instagram side of things. He also goes into detail why they were kind of forced into this approach in contrast to what they had before. Yes, and that's it from my side. Are there any questions?